Hello there. You kind of startled me. Can you guess what the topic for today's show is? If you said, it's about colors, you're right. So stay in your seat and stick around for a while. I'm going to teach you all about colors, Dr. Quack style. Welcome back. I'm Dr. Quack. I hope you're ready to learn because we have a lot of exciting things to show you today. But first, let me introduce you to my assistant, Dizzy Izzy. Dizzy Izzy! I said, Dizzy Izzy!
You called?
Yes, I did. Today, we're going to teach all our friends at home about colors. Would you like to assist me?
I sure would. Hi, everybody.
Dizzy Izzy, do you know what colors can tell us about an object?
I'd have to say I'm drawing a pretty big blank here. What do they tell us?
The color of an object tells us the kind of light it reflects. Let me explain. When something reflects, it bounces off of something and comes back. For example, when I look at myself in this mirror, the image of my oh-so-handsome self bounces off the mirror and comes back and tells my brain what I look like. Do you know what the opposite of reflect is?
No.
Let's take a look at this sponge. Now, what happens if I pour water on the sponge? It absorbs the water.
So absorb is the opposite of reflect.
That's right. Now that we know what absorb and reflect mean, let's talk about what happens when light hits different objects and how that lets us see colors. Light travels in waves, just like water travels in waves. When we measure the distance between the peaks or tops of two waves, we call that the wavelength. Wavelengths are what determines the color of the light.
So blue and yellow come from different lengths of waves.
Exactly.
So what wavelengths make what colors?
Ooh, that's a great question, but the answer is pretty complicated, so pay attention. Short wavelengths give us violet and blue shades. Medium wavelengths give us yellow and green shades. Long wavelengths give us orange and red shades. When the wavelengths hit an object, the object either absorbs or reflects the wavelengths. Whichever wavelengths are reflected, those are the colors we see. For example, when light shines on this nice ripe banana, hello? It absorbs the short and long wavelengths and reflects the medium ones. So we see that the banana is yellow. Now, when light shines on this object, it absorbs the short and medium ones and reflects the long wavelengths. So we can see that the shoe is red.
Factoid Phoebe here. Did you know that scientists believe dogs can't see colors? The parts of the eye that see colors are called the cones, and dogs have very few of these. Dogs most likely only see black, white, and shades of gray.
Dizzy Izzy, do you know what this is?
No, but it's really colorful.
It's a color wheel. It shows the primary, tertiary, and secondary colors.
Tresha, what?
It's tertiary, but let's start at the beginning. The primary colors are red, blue, and yellow. All the other colors are a combination of these three.
Get out!
I'm serious. Mixing red with blue makes purple. Yellow and blue make green, and red and yellow make orange.
That's so cool!
Dizzy Izzy, now I think it's time for an experiment. Would you help me out by gathering the materials we need?
Sure thing, Doc.
Whoa, that was fast. What all do we have in there?
We have some paper, some blue paint, some red paint, some yellow paint, and some paintbrushes.
Ooh. All right, now I'm gonna show you how to mix these colors together to get different colors.
Awesome! What color will you make first?
I think we'll make purple. Okay, first, you put a piece of paper, take a little bit of red paint, and put it on this side. Now, we're gonna take some blue paint and put it on the other side. Okay, now we're gonna mix a little bit of the blue and a little bit of the red in the middle and see what happens. Get a little more blue in there. Whoa. What do you think?
I think it makes purple.
Let's do another one. Let's try orange next. Get a new piece of paper out and a clean brush. Now, put a little more red on the one side. And we're gonna need our yellow paint. Put some yellow paint on the other side. Now, to get orange, we're going to put a little bit of red and a little bit of yellow in the middle and mix them together. Let's see what happens. Here comes the red. Still looks kind of like red. Let's add a little more yellow. Whoa! It's starting to change colors.
It's making orange, just like you said.
let's try one more color. Dizzy Izzy, do you want to try?
I sure do.
Okay. Let's get another clean white piece of paper. And this time we need yellow and blue. Okay. We'll use our blue brush again. Put blue on one side of the paper. And Dizzy Izzy, you see if you can finish up.
Thank you.
Now, put a little bit of the yellow in the middle and a little bit of the blue in the middle.
I like painting.
Looks like it's starting to change color.
It's making green! This is so cool!
You guys can go ahead and try this for yourselves at home. What is your favorite color and why?
My favorite color is blue because it kind of reminds me to just go with the flow.
My favorite color is red because it reminds me of roses. My favorite color is green because it's my birthstone color.
Now, what was that big word? Tresha, Tersha, turkey. Oh, what was it?
Tertiary. A tertiary color is a primary color mixed with a secondary color. For example, take the primary color blue, mix it with the secondary color green, and you get blue-green.
Oh, I love that color.
The primary colors are red, blue, and yellow.
The secondary colors are purple, orange, and green.
You get a tertiary color when you mix a primary color with a secondary color. Now we're going to learn about Roy G. Biv.
Roy who?
Roy G. Biv. And he's not a person.
He's not?
Nope. It's just a simple way of remembering the order of the colors of the rainbow.
Oh. Okay.
When you see a rainbow, the colors are always in the same order. And this is a simple way to remember them. R, red. O, orange. Y, yellow. G, green. B, blue. I, indigo. And V, violet.
Did you know that a rainbow was mentioned in the Bible? After the flood, Noah saw a rainbow. God said that it was a promise that he would never flood the entire earth again.
Dizzy Izzy, are you ready for another experiment?
I sure am. What are we gonna do?
First, let me show you what we need. The first thing we need are a pair of scissors. Next, a coffee filter. Then we need... Whoa! How did he get in there? And a black marker. Also, we need a cup of water.
What's next?
Well, the first thing you do is cut out a strip from the middle of the coffee filter. Make it about 1 inch wide. Then, we're going to take the black marker and draw a big thick line on one end of the strip.
What exactly are we doing?
Did you know that black ink isn't made up of just one color?
It's not?
Nope. Sometimes it has other colors in it. And what we're doing is called chromatography. I'm going to take this strip and dip the end with the black line in the water. When the water travels up the strip, the colors will separate.
That sounds awesome!
Okay, here we go. Well, the water is touching the strip, and I think it's absorbing it. There we go, it's going up. Let's see if there's any colors other than black in here.
Whoa, it's turning blue!
The colors are separating as the water is absorbed.
It's making green swirlies.
Mm-hmm. Wow. See? Black ink has more than one color inside.
That's amazing!
What colors are in the rainbow?
The colors of the rainbow are red, orange, yellow, green, blue, and purple. The colors of the rainbow are red, orange, yellow, green, blue, and purple.
The colors of the rainbow are red, orange, yellow, indigo, green, indigo, and purple, violet.
Did you ever wonder why the sky is blue? The Earth's atmosphere is made up of a mixture of gases. When light from the sun hits these gases, the color blue is reflected, and that's what we see.
There are so many different colors that God put in nature. The big, beautiful blue sky is one of them. Dizzy Izzy, can you think of another one?
How about the leaves on a tree?
That's a great example. But do you know why?
Why?
Well, because in the springtime, when the trees bloom, their leaves are green. But in the fall, they change colors. They're a variety of color.
I never thought of it that way.
Yep. Do you know where the color in the leaves comes from?
No, but I'm sure you'll tell me.
You bet I will. Chlorophyll is what gives leaves their green color. Chlorophyll absorbs the red and blue light from the sun and reflects the green light, making the leaves appear green. Leaves are nature's food factories. Plants take water from the ground, through their roots, and take a gas called carbon dioxide from the air. Plants use sunlight to turn water and carbon dioxide into glucose. Glucose is a kind of sugar that the plant uses as energy and also as a building block for growing. The way plants turn water and carbon dioxide into glucose is called photosynthesis. This means putting together with light. Chlorophyll helps make photosynthesis happen, but chlorophyll is not a very stable compound, which means that bright sunlight causes it to break down. To keep the right amount of chlorophyll in their leaves, plants are always making it. The making of chlorophyll requires sunlight and warm temperatures. So, during the summer, chlorophyll is always being made in the leaves. As summer ends and fall comes, the days get shorter and shorter. This is how trees know to begin to get ready for winter. During winter, there is not enough light or water for photosynthesis. The trees will rest and live off the food they stored during the summer. They begin to shut down their food-making factories, and the green chlorophyll disappears from the leaves. As the bright green fades away, we begin to see the yellow and orange colors. Small amounts of these colors have been in the leaves all along. We just didn't see them in the summer because they were covered up by the green chlorophyll. In some trees, like maples, glucose is trapped in the leaves after photosynthesis stops. Sunlight and the cool nights of fall cause the leaves to turn the glucose into a red color. The brightest autumn colors are produced when dry, sunny days are followed by cool, dry nights.
So you're saying that the green leaves actually have the reds and yellows in them already?
That's right. The chlorophyll that makes the leaves green reflects the most light. So we see the green and not the other colors.
That's pretty cool.
It sure is. God really knew what he was doing when he created trees.
You can say that again.
God really knew what he was doing when he created trees.
Do you know what else in nature is really pretty?
What?
Flowers.
They sure are. Did you know that there are 3 different pigments that give flowers their color?
No, and I also don't know what pigment means.
Pigment is just a fancy word that means something that gives color.
Okay, well, let's learn about pigments.
There are 3 different pigments that give flowers their color. The first is flavonoids, which produce red through blue colors. They are quite common in roses. Carotenoids produce yellow and orange coloring. They're found in sunflowers and marigolds. Chlorophyll, the 3rd pigment, gives plants their green color. Did you know that you can actually change the color of some flowers?
How can you do that?
The flower called the hydrangea can have its color affected by 2 things: the amount of light it receives and the type of soil it's in. If the soil is highly acidic, the flower will be blue. If the soil is neutral or only a little acidic, the flowers will be pink. Would you like to see how pigments can change colors in different environments?
We can do that here?
We sure can. We just need a few ingredients. First, get 3 clear plastic bowls. Then, we're going to need some white vinegar, some bleach. Now be careful with the bleach. You should only let adults handle it. And some water. Oh. The last thing we're going to need is a little bit of purple grape juice. Now, the first step is to pour equal amounts of water, bleach, and white vinegar into the 3 clear glass containers. White vinegar, the bleach, and the water. Easy does it. Here we go. Okay, the next thing we're gonna do is put a little bit of grape juice into each of the containers and see what happens. Dizzy, would you like to help me?
Okay.
All right, let's try the water first.
Nothing really happened.
Well, that's because the water is neutral, and that's how grape juice reacts with water. Let's try the vinegar next.
Whoa, it's really dark.
That's right. That's because the vinegar is highly acidic, and that's how grape juice reacts with vinegar. Last but not least, let's try the bleach.
Whoa, it disappeared.
Wow, let's try it one more time.
Wow, that's amazing.
That's how the grape juice reacts with the bleach, because the bleach is alkaline.
I've learned so much about colors today.
Let's see how much you can remember. Are you ready?
I am.
Which colors do we see? Ones that are reflected or absorbed by an object.
We only see the colors that are reflected by an object.
What are the 3 primary colors?
The answer is red, yellow, and blue.
What are the secondary colors?
green, purple, and orange.
What is a tertiary color?
It's when you mix a primary color with a secondary color.
What is the order of the colors in the rainbow?
All I have to do is remember Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet.
Who did God make a promise to by showing a rainbow that he'd never flood the entire earth again?
That one's easy. Noah.
I can't believe it's time for us to go already.
I know. I was having so much fun.
Well, there's always next time.
Yay! I can't wait!
And remember, the world is full of fascinating things to learn about. And since God created the world, he is the ultimate scientist. We'll see you next time right here on Super Simple Science Stuff. Bye-bye.
Bye!
That's science.
If you